So for the part 2 of this project, the surface area and volume, I would like to present about our calculation. So the first one is surface area using integrator. So we got the surface area of the school. The first one is upper pi hemisphere. So I got from GeoGebra, the equation is square root 4 minus x squared minus y squared. And then we differentiate it dz dx, dz dy, and we get this. And then we square the differentiation, and we got x squared minus 4 minus x squared minus y squared. And for dz dy, we square it and got y squared over 4 minus x squared minus y squared equals to square root x squared plus y squared plus 4 minus x squared minus y squared over 4 minus x squared minus y squared. And then, as we know, from what I learned, x squared plus y squared is equal to r squared. So that's why we got 2 over square root 4 minus r squared. So for surface area, double integral RD theta. As we know, hemisphere is a shape of a circle. So this is the shape of the circle. I want to find the surface area of this. So this is 2 pi. This is the total surface area. So that's why, and the radius is 2. So from here we got 2 pi 0 2, and then we differentiate it by substitution. So I let u equals to 4 minus r squared, and then differentiate in terms of r, get minus 2r, and we arrange the range to equals to this equation. And then we got negative 2u power of 1 over 2. And then we go back to here. And then we substitute back u 4 minus r squared into this equation. And then we put 2 here. And then I got 0. I put 0 here. And then I got square root 4, which makes equal to 2. And then we differentiate it for d theta, and then we got negative 4 theta that's by 2 pi, and then we got 8 pi. So the next one is surface area of cone. So I got equation z equals to x squared plus y squared. We differentiate it in terms of x and y, you get this. And then for the surface area, or using the formula square root 1 plus dz over dx squared plus dz over dy squared, and then we got this full equation. And then we cancel it out. This is equal to 1 square root 2 RD theta. And then so the cone height is 0 to 1, the radius is 1, and then we derive it, we differentiate it in terms of r first, and then we derive it, and then we differentiate in terms of d theta, and we got square root 2 pi. So value of this volume of screw, integral part. So for volume of screw, the first one, I start from the top, which is hemisphere. So V dV equals to 0 to 2 pi, pi to pi over 2, and then 0 to 2. This is because I got the equation like this. So this is pi, this is pi over 2. So we got the angle 45, it's 5 dB. And then the radius is 2. So we got 0, 0 and 2. And then we derive it in terms of theta, we got this, negative 8/3. And then differentiate it in terms of phi, we got this. And then we differentiate it equals to, in terms of theta, we got 8/3 theta. And then we use 2 pi and then insert it, we got 16/3 pi. So the next one is the middle part, which is cylinder. So the height is 2 to 12, 0 to 2 pi, and the radius is 1 to 10. So for cylinder, it's using r d theta dz. So the radius is 2, 12, 0 to pi. So as usual, we integrate for the r part first. So we got r squared over 2. And then we insert 1, 0. We got 1 over 2 d theta dz. And then we differentiate in terms of d theta. We got 1 over 2 theta. And then insert 2 pi, and then we got pi z. And then we differentiate in terms of z, we got pi z. And then insert 12 2. 12 pi, and then minus 2 pi equals to 10 pi. So for the cone pi, radius is 0 to 1. So 0 to 2 pi and 2r to 2. This is because the height of the cone radius is 1. And then the height is 2. And this is 1. So I got 2 over 1r. That's why I got 2r. That equals to 2r. And then as usual, we differentiate into z, but I do it differentially from usually. And then we got 2 minus 2r, and then we differentiate in terms of theta first, 0, 1. And then we got 0 to 2 pi. And then we bring 2 pi outside. We got this 2r and minus r squared dr. So integrate, we got r squared r cubed over 3. And then we put 1, so equals to 1 minus 2 over 3, we got 1 over 3. And then we times by 2 pi, and we get 2 over 3 pi. So we are using conventional method for surface area and volume. This is to prove that our calculation, the integration is true and same. So first one, surface area of the screw, we got the radius is 2. We just calculate it, and then we got 8 pi. So the cone, we have to calculate the slant height. So this is L, this is H, this is R. Then we got L equals to 2 square root 2. So we got the final answer 2 square root 2. Surface area of the slant height. So we got the formula is pi RL. L is slant height, R is 2, and then you get 4 square root 2. So volume on the screw, as usual, we using the 2 over 3 pi r cube, we substitute the 2 here, there, and it equals to 16 over 3 pi. So the cylinder, pi r square h, so the r is 1, we got 10 pi. So cone 1 over 3 pi r squared, you got height 2, and then you got 2 over 3 pi. So the total volume is 16 over 3 pi plus 40 pi plus 2 over 3 pi, and we add it equals to 60 pi. So that's all from me. Thank you.